Hello, this is Memphis Communiversity. We are practicing some AP Calculus free response questions, and today we are doing an accumulation free response question. So accumulation free response questions are usually the first free response question on the AP exam. They include rate-in and rate-out free response questions, as well as questions that have where the amount is given and where just a single rate is given. But in this case, we are doing a non-calculator version, so that's why it is difficulty number 5 out of 10. We go from difficulty 1 through 10 for each free response question topic. So this one won't be any harder than our difficulty number 2 video, I believe, because that one is a very standard rate-in and rate-out question. But in this case, we have the same thing, a rate-in and a rate-out. But of course, we have not a calculator, so we're going to have to do integrals without a calculator, basically. So, of course, the rules will still be the same. We're going to be focusing on how to find different amounts, amount over a time period, amount at a time. So let's get started. So it looks like my friend here is working at a camp, and she needs to keep track of the number of campers at this camp. The camp has 2,500 campers at t equals 0. Why did they give you that information? That is for Fundamental Theorem of Calculus eventually, when we want to find the amount at a different time. Then it says, it's nice to be able to glean information from a paragraph without, while we're trying to notice what the most important thing is. So in rate in, rate out FRQs, which are an example of accumulation FRQs, it's going to be the rate in is important. So the rate that the campers are joining the camp. And then how fast they're leaving as well. Rate out is this. And then the units of these are hundreds of campers per week. So let's get started. Let's do an easy question to just to get used to it. Is the number of campers at the camp increasing or decreasing at t equals 2? So this is going to be seeing whether rate in is bigger or rate out is bigger at t equals 2. So what we're going to do is we're going to just do rate in minus rate out, plug in 2, and just see if it's positive or negative. This happens to be what I call a prime of t. So in the later part of the free response question, I'm going to use a of t as the amount of campers in the camp. And while the rate of change of the amount is a prime, that's going to be r of, in this case, j of t minus L of t. And if you want to see if anything is increasing or decreasing, so for example, in this case, the number of campers, the amount of campers in the camp, what you want to do is you want to take the derivative and just see if it's positive or negative. So again, that just entails seeing whether j of 2 minus L of 2 is positive or negative, because in this case, j of t minus L of t is the derivative. So just be careful. We're not going to take a derivative of the givens because they are already derivatives. They are rate-ins. Where's the word rate-in? Not rate-in, the rates. And so this should be by the rate, j of t. So these are both rate-ins. So what we're going to do is we're going to plug in 2 here. If we wanted to see whether the rate-in was increasing or decreasing, then we would take the derivative of one of these. But in this case, they're already derivatives. The derivative of amount being rate-in minus rate-out. So all we're going to do is we're just going to plug in 2 here. So it shouldn't be too bad. 18 times 2 minus 6 times 2 squared. That will be plugging into j. Plugging into L would be minus 2 times 2 plus 14. Just like normal, I'm being very careful with parentheses. I'm wrapping both rate in and rate out in parentheses. And then let's just see if I can do any math, which is a question. I might not be able to, but looks like 18 times 2 is 36. 6 times 4 is going to be 24. If we keep going, negative 4 plus 14. So it looks like we're going to have 12 minus 10. So that's 2. And the only important thing about this number is that it's positive. I'm running out of room. Forgive me, please. But this is positive, which means that the number of campers will be increasing. So the number of campers, we'll just write it in this box right here. There's a lot of space here. Might as well make use of it. Number of campers is increasing because rate in minus rate out at 2 is equal to 0, is greater than 0. So that means rate in is bigger than rate out. If you did have a calculator, then you would just plug in, of course, 2 into these functions and subtract with the calculator. We do the same thing when we don't have a calculator. We just have to compute the numbers for ourselves. So again, you want to be careful about what is increasing or decreasing. In this case, it's the amount is increasing or decreasing. So we found the derivative of the amount, which happened to be rate in minus rate out. The rate of change is rate in minus rate out of the number of campers. But if they wanted to say, for example, whether this was increasing at an increasing rate or decreasing rate, meaning is the rate increasing? So we have an increasing function, but we want to see if the rate of change is increasing or decreasing, if that makes sense. We would want to take a derivative of j and L, so j prime minus L prime, and plug in 2 there. So anytime you have an increasing, decreasing question, just find what you want to know is increasing or decreasing, and then take that derivative. But usually students are pretty good with that. So in this case, let's keep going. Let's talk about amounts. So there's 2 amounts if you've watched our videos in difficulty number 2 and 3, I believe. So there's amount over a time period, meaning the net change of a rate over a time period. And then there's the amount of campers at a time. So this is going to be over a time period. How many hundreds of campers joined the camp during the first 2 weeks? So remember that amount over a time period usually involves either just rate in or just rate out. How many campers joined the camp? How much water leaked out of the tank? How many people joined the concert, exited the concert, things like that. So notice there's only a verb where it indicates whether you should use only rate in or only rate out. Also, we have an initial amount, but we don't use it in this question because the initial amount has no bearing on how many came during the first 2 weeks. The initial amount will come in when you want to find the amount at a specific time, because then it will be affected by the initial amount. So in this case, amount over time period is always just the integral of rate in or just the integral of rate out. So in this case, it's the integral of rate in. And then you don't add the initial. You will see the difference when we do amount at a time. In this case, first 2 weeks does imply 0 to 2, so that's great. Also keep in mind that some people get confused when the units are a little bit confusing like this, where we are doing hundreds of campers as opposed to just campers. But we're not going to do anything weird. Like, we're not going to change this to 2,500, or we're not going to try to multiply everything by 100 and add a lot of zeros. What we're going to do is we're just going to take this integral, and then our units aren't going to be campers. It's just going to be hundreds of campers, as you'll see. So again, I'm just going to do this integral. If I had a calculator, I would just type this bad boy in. But in this case, I am left to fend for myself. I have to take this integral right here. So it's the integral from 0 to 2 of 18t minus 6t squared. Certainly not the hardest integral that I've ever seen before. This is going to be, so this is 18. This is going to be the power rule for antiderivatives. So this is technically t to the 1. So when you add 1, it's t squared. We're going to flip the new exponent, or that's the same thing as multiplying by the reciprocal. So it's going to be 18 times 1/2, which is 9. That is the power rule. Then we're going to take the antiderivative of this. Same rule, add 1, so it'll be t cubed. Flip this bad boy, so it'd be 6 divided by 3, which is 2. And that is the antiderivative. Then we are going to plug in 2 and 0, because Fundamental Theorem of Calculus. So when we plug in 2 here, not going to be too bad. 9 times 2 squared, we'll do that later, minus 2 times 2 cubed, that's 8. We can just write it like this first. Plugging in 0 is quite lovely. I'm still going to put it in parentheses just to be safe. If you're plugging in 1, for example, you would need to have the number 1 in both slots. And then the subtraction is needs to be distributed. So this negative is what I'm being careful about. So that's why I always put top minus bottom, sort of like rate in minus rate out, all wrapped in parentheses. Parentheses are our friends. But of course, when you plug in 0 in this case, you do get 0, so you really don't need to worry about it too much. So now we're going to do this thing right here. So 9 times 4 is 36, minus 2 times 8, because 2 cubed is 8. That's going to be 16. So our final answer is going to be 20. But remember, let's just try to practice with units. I don't put units unless they ask me to, but in this case, there's no pressure. The units of this will be hundreds of campers. It's an amount of campers. Hundreds of campers. Notice that I'm not writing like 2,000 campers. It's just easier just to keep the units consistent throughout the question. But again, This is the amount formula over a time period. Always either the integral of just rate in or the integral of rate out. Do not add the 25 in the front because 25 doesn't affect the net change of the rate in from time 0 to 2. So this is very typical stuff, except that we don't have a calculator, of course. So now we're trying to find the total number of campers in the tank at t equals 2. So this is the amount formula. So let me write this formula out because it is the most important formula on these accumulation rate in, rate out free response questions. So a of t is going to be a of 0 plus the integral of 0 to t. So I'm only using 0 because the initial time is 0. A lot of times in these free response questions, the initial time is 0. Probably like 90-95% of the time, but be careful, sometimes it's not. A second thing is that, for example, this is the same formula as the position formula in particle motion free response questions, and there sometimes the initial time is not 0. So just be careful. It's not always 0, but it's 0 a lot of the times. Then we're going to write rate in minus rate out here. So we're going to write j of x minus L of x. So this is the fundamental theorem of calculus. One of my best friends in the world. I am a little bit weird. And this is the amount, what I call the amount formula. Same thing as the position formula and particle motion. Same thing as parametric, and the position formula and parametric when you do both coordinates. Same thing when you're finding f of x and graph free response questions. It is very important. It is the fundamental theorem of calculus. So how it works is you always put the derivative, the antiderivative of the derivative, of course, is the function minus the bottom number, so we bring it over, and that's why we get this formula. So it's always initial amount, time period 0, and then want time. So if we want to find 2, we're going to plug in 2 into the top. What we do is we first, while these functions are defined as t functions, we are being a professional, and we are changing these variables from t's to x's. Because when we plug in a number like 2, for example, we do not want to plug it inside the integrand. We only want to plug it into the top thing and just keep these as x's. This works the same way with the calculator, of course. So in this case, we are going to find a of 2. A of 0 is 25 because there's 2,500 campers at the beginning. So it's 25 plus the integral of 0 to 2. Then it's going to be j of x. So we're going to write 18t minus 6t squared. Can't really talk. So it's 18t minus 6t squared. Let's look for L of t. It's going to be negative 2t plus 14. Again, I'm being very careful with parentheses. And then this is the setup of, let's use x's actually. Sorry, let's change these to x's. Again, we're trying to be civilized. We use x's over here, so we might as well use x's when we do this. So hopefully you can read that. So we are ready for this integral, but before we do the integral, oftentimes it's good to simplify anything that you're taking the derivative of or the integral of. So let's do that first. So what we're going to do is we're going to write 25 plus the integral of 0 to 2. Just a quick little simplification step. I cannot pronounce that word. Simplification step to make our lives easier. Let's try to combine things that are same. Hopefully you can read this because I made it really messily. But 18x minus 2 is 18x plus 2x, so that's going to be 20x. And then minus 6x squared, that's what this says, if you can read it. And then this is minus 14 at the end. So again, it is good to be careful with negatives because this negative does distribute. Then we are going to take this integral. So we're going to write 25. Then we are going to write plus, and we are going to take the antiderivative. Same thing from the first page. The antiderivative of 20x is 10x squared by the power rule. You add 1 to the exponent and then divide by the new exponent. This antiderivative is still going to be 2x cubed. Add 1, flip the new exponent. So add 1 is 3, divide by 3, 6 divided by 3 is 2. And then finally, minus 14x at the very end. The antiderivative of any constant by itself is that constant times the variable. We're going to use the vertical bar notation, which means I'm going to plug in 2 and 0, and we are almost done. Bear with me, friends. We can do it. So when we plug in 2, we're going to get 2 times 2, which is 4 times 10. So it's going to be 40, I believe. And then it's going to be 2 times 2 times 2 again, times 2, which is 16. and then 2 times 14, which is 28. We do have to plug in 0, but plugging in 0 is the best thing in the world because it looks like we're going to get zeros across the board. So to finish this out, what we need to do is we just need to find and simplify this. So let's just draw an arrow because I'm running out of room. So in this case, 40 minus 16 minus 28. So let's do this. So I'm going to add these two. I'm going to add these two and then subtract the answers. So 40 minus 25 is 65. Now let's see how bad my math is. It's going to be minus. So 16 plus 8, 28. I can't even read the question before I even do the math. So 16 plus 28. Well, that's 28 plus 6, which is 34. And then 34 minus plus another 10. So I believe 28 plus 16 is 44. And I can do this math in my head. 65 minus 44 is 21. Don't be ashamed if you want to do math on the side. Definitely no shame in getting things right and being careful. So if you want to do adding and subtracting and multiplying on the side, just put it in the corner. And then you should be good to go. So 2,100 campers. There's 2,100 campers at time is equal to 2. So we can write hundreds of campers to be more precise. And that is the answer. So what I want to focus on, what I want my students to focus on when I teach this is the difference between the amounts. So again, there's two main differences. So there's two main questions. So it's amount over a time period or amount formula at a given time. Do you want to find how much sort of changed over a time period? That's this one. Or do you want to find how many things were there at a specific time? So the two main differences are when you're going at a time, it's reliant on how much you start off with, which is why we add it to the front. Also, it's reliant on both rate in, rate out. The amount at a time depends on how many campers are leaving and entering at any time. Amount over a time period does not rely on how many you started off with because you only care about that one time period. So you do not add the number in the front. And also you're usually finding the amount over a time period of one of the rate in or one of the rate out, but not both. So it's usually just the integral of one of them as opposed to the integral of rate in minus rate out. So hopefully that makes sense. If you practice some of these videos with us, for example, again, our difficulty 3 video, even when we go to some of the harder ones after this video, like piecewise functions, it still works the same way. Amount at a time, which is more important than amount over a time period, is the initial amount plus the integral of rate in minus rate out. And why is it important? Because you use it quite a bit. For example, in the last question, most rate in, rate out questions, most accumulation questions that I've seen before on the AP exam, you have to do the absolute max or min process. It's called the closed interval method. You can watch our video on the closed interval method. We have videos on that, of course, on our channel. So please check that out if you want to practice. But for now, let's just do this question. So when I do the closed interval method, I first want to find the thing I'm taking the absolute max or min of. In this case, we're finding the absolute max or min of the number of campers. So I am going to do the absolute max or min of the amount formula. So in this case, it's going to be A of t equals 25 plus the integral of 0 to t j of x minus L of x. So the same amount formula from before. One thing is that some students get too eager and they want to plug in 2 already when we go from 0 to 2, but you want to avoid that. You want to keep this as a function. You want to be able to plug in a lot of times, not just 2. So we're going to keep t separate here. We're not going to plug in 2 yet because then it'll become a number. It'll actually become 21 because you'll be able to do this integral. So we want to still be able to plug in numbers. So we're going to keep it with a t. Where does 2 and 0 come in? That'll be in the third step when we do the table. Those will be included in the table because the endpoints are always included in the table because they are candidates for maxes and mins. So what we do is we're going to just, let's just simplify this before we actually take the derivative, which is the second step. So it's going to be 25 plus the integral of 0 to t. And then I'm going to write out this step right here because this was rate in minus rate out simplified. So it's 20x minus 6x squared minus 14. So it's 20x minus 6x squared minus 14. So we have found the thing we're taking the max or min of. I like to do this step because when I plug in numbers, it will be easier if I see it on the page in my own handwriting. Number 2 is critical point steps. That means you take the derivative, set it equal to 0. Remember, just set that derivative equal to 0, write it out explicitly, and you might get a point for that, even if you do find the zeros incorrectly. So a prime of t, again, the derivative of the amount formula is rated minus rate out. That's the rate of change of the number of campers. So we have j of t minus L of t. We're going to set this equal to 0. If you didn't know that, well, the derivative of this function right here, the derivative of 25 is 0 because it's a constant. And then the derivative of an integral, that's the second part of the fundamental theorem of calculus. When you take a derivative of an integral, they basically do nothing because you just did one thing and reversed it. So all you do is you plug in the t's. So that's why you get j of t minus L of t. So in this case, we're going to plug in t into this. So it's going to be 20t minus 6t squared minus 14 equals 0. Whenever you have a quadratics equal to 0 and you don't have a friendly calculator to help you out, what you want to do is you want to try to factor it. So when I try to factor it, I want it of the form where my squared is in the front, of course, where I try to simplify as much as possible. It looks like I can divide everything by -2. So I'm going to do that. So it's going to be negative t plus 3t squared plus 7, I believe. And why am I doing this? Because I like to rearrange again so that my t is in the front and it's positive. It helps me factor. But you're probably factoring masters, I'm assuming. So you factor however you like to factor. Unfortunately, if you can't factor, you always have the backup option of the quadratic formula. Finally, we're going to factor this. This looks kind of intimidating to factor, but I believe it does because it's minus 7 minus 1. Minus 7 times minus 1 is 7. Minus 7t minus 3t is minus 10t, so we are good to go. These zeros are 1 and 7/3. So now we have 1 and 7/3 from this. So now we're ready for the third step. The most annoying step, we don't have a calculator, which makes me sad, but we can do this. I believe in us. So when you construct this table, always the endpoints go into the table because those are potential maxes or mins. And then also any number that fits within that interval, any critical point that it fits within that interval. So in this case, it will only be 1, thank goodness, because I do not want to deal with 7/3. But 7/3 is slightly bigger than 2, and we only care about the times between 0 and 2. We don't care about what are the maxes outside of that interval. So that's why we're not going to include 7/3 into this table. So we are ready for the right column of the table, a little bit trickier. What we're going to do is we're going to individually plug in these 3 points into the amount formula. So we're going to plug in 0 into this guy, just into the top, not into the integrand like normal, 1 and 2. So this is going to be a slightly annoying process, but we can use our past selves to help us. When we plug in 0, any integral from the same number to the same number, so from 0 to 0, 7 to 7, pi to pi, whatever, there's no area underneath it, so it's going to be just this number. And from the very beginning, a of 0 has been 25, so everything is consistent. So that number wasn't too bad. Now let's plug in 2 actually. So when we plug in 2, we're only plugging it into the top. So we have to do this integral, unfortunately, but we actually already did that. When we plugged in 2 here, we found the amount at 2 already. So we're just going to use this past answer. Hopefully we were right. It was 21. Now we're going to find a of 1. So if you look at this work when we did 2, instead of plugging in 2, we would be plugging in 1. So we would be plugging in 1 in the top right here, 0 on the bottom. So when we would plug in 1, that's going to be pretty nice. And then when we plug in 0, it'd be minus 0. So when we plug in 1, hopefully you can just see it. We don't have to write anything. When we plug in 1, it'll be just 10 minus 2 minus 14 because 1 to any power is 1. So 10 minus 2 minus 14. What is that? Well, that's going to be 10 minus 2, which is 8. 8 minus 14, which is negative 6. And then 25 minus 6 is equal to 19. So this is going to be 19. Again, how I did that is I plugged in 1 in here, right here, and then I took the antiderivative, did top minus bottom, but I already did the antiderivative in the previous step, so I didn't want to do it again. So it looks like we're actually done. It looks like the max is going to be here, and the min is going to be here. So let's write that out. I don't know where we're going to write it because I don't have a lot of space, but let's try writing it right here. So at t is equal to 0, abs ABS standing for abs. You shouldn't abbreviate like I am, but I am being a hypocrite. But abs max of 2,500 people or campers. Great. And then at T is equal to 1. Abs min of 1,900. And that is all she wrote. So again, for this entire free response question, this has been a very standard rate in, rate out free response question, probably even easier than other questions because the functions were so nice. But unfortunately, we did have to do everything by hand, so take integrals by hand and things like that. But the questions were very standard. Seeing whether the number of campers was increasing or decreasing, that just took we just took a derivative, which is just rate in minus rate out. So we actually didn't do very much. Keep in mind though, if we were trying to see if the rate n was increasing, we would only plug in, we would find the derivative of the rate n, so j prime, and then plug in 2 into that. So you want to be careful with your increasing, decreasing questions. What is actually increasing or decreasing? Find the thing you're trying to see if it's actually increasing or decreasing, and then take the derivative. So for example, if they ask whether the rate of change of the number of campers was increasing or decreasing, we would need to find j prime minus l prime, because that's the derivative of j minus l. So hopefully that makes sense. The next thing we did is we focused on the different amount questions, amount over a time period, just the integral of rate in or rate out, no initial in the front. And then we unfortunately had to do this antiderivative, but it wasn't too bad because we used power rule. Amount at a time is more important. That does include the initial time added, and then we use both rate in and rate out. Finally, max or min is usually of the amount formula in these accumulation free response questions. So we rewrote the amount formula, took its derivative, which is rate in minus rate out, factored it because we didn't have the use of a calculator. If we did have the use of a calculator, we could have perhaps graphed this calculator and found the zeros using the calculator. Then once we found these zeros, we only put the one that fit within our endpoints, and then we plugged in these 3 numbers slowly into this guy right, moved up too much, this guy right here for any of these two, and then we were able to do the antiderivative again and find these 3 numbers. Biggest number is the absolute max, smallest number is the absolute min. So hopefully that was useful for you. Again, this free response question wasn't any harder than any other ones, except that it was non-calculator. You shouldn't expect the accumulation free response question to be non-calculator because there's so many good choices for non-calculator free response questions, like differential equations, graph free response questions are always non-calculator. But in the past, the accumulation free response questions have been calculator. It's still, of course, important to know the rules. So try to sort of remember how to tell whether something is increasing or decreasing, no matter if it's the amount of stuff or the rate, and also know the differences between the 2 amount formulas. But we're only at difficulty number 5. There's still 5 to go. Difficulty 6, 7, 8, 9, and 10. So we're going to see variations of this free response question where we might actually have a calculator, but for example, sometimes they give just the amount actually instead of the rate, or sometimes they give the amount for one of the functions, but then the rate in or rate out of the other one. And then the most difficult questions, sometimes one of the rate in or one of the rate out is piecewise. So be on the lookout for that if you want a little bit of a challenge. But thanks again for joining me. We really do appreciate you watching this video. We really want to help you guys out. So hopefully this allowed you to understand how to do accumulation free response questions. Until next time, friends, and good luck.